Good morning, everyone. Give us a couple of seconds to let everyone in. Welcome, good morning. We'll get started around 9:25. This is part of our series of periodic updates on the Clearwater project, the construction of a new 7-mile long tunnel from our largest wastewater treatment plant. So we'll get started around 9:30, but welcome everyone, and thank you for joining us. Good morning, everyone. We'll get started in about 1 minute. Just waiting for more folks to trickle in, and we'll get started with one of our periodic updates on the Clearwater construction project. Thank you for joining us on a lovely Saturday morning in LA County. All right, good morning. It's 9:30 on the dot. I'm your warm-up act. I'm Basil Hewitt. I'm an engineer with the sanitation districts. And this morning we have Glenn Acosta, also an engineer with the sanitation district. Glenn has been the primary lead on outreach for this project, which we've been planning and designing for a number of years and making sure we're getting community's input in it every step of the way. And we also have Russ Vicaria, who's the construction manager for this construction project, largest construction project in our agency history, and it supports our largest wastewater treatment plant. So I have a few words of housekeeping before I hand it over to Glenn. If you have any questions, put it in the Q&A feature, which is at the bottom of your screen. If you're on an iPad or a mobile device, it should be in your upper right-hand corner. If you like, and which is our preference, raise your hand. We'll unmute you and you can ask your tough questions to Russ or Glenn. I think that's about it. And if you have questions that are pertaining to a particular slide, we may take those, offer those up, but most of your questions, if you could hold them to the end, then Russ, Glenn, or I will be able to answer them. So with that, welcome. Thank you for joining us in virtual update on construction for the Clearwater Tunnel. And with that, I'm going to hand it over to Glenn Acosta, Senior Engineer at the Sanitation Districts.
Good morning, everyone. Thank you for joining us today for our presentation on how we build modern tunnels. And before I hand it off to my colleague, Russ Vicaria, who's overseeing the construction of the tunnel, I thought I would touch on who we are and why we're building a tunnel. So our agency, the Los Angeles County Sanitation Districts, manages the sewage, or what we call wastewater, for over half the population in the county, 5.6 million people. Our service area goes from the South Bay all the way to the Antelope Valley. And we manage the sewage by directing the flows to our 11 wastewater treatment plants, which are shown here in the green pins. Our largest plant is in Carson, called the Joint Water Pollution Control Plant. It is the hub of the main sewer system that serves the southern half of the county. Sewage flows into the plant, and in less than half a day or 12 hours, it gets turned into clean water, and that clean water goes out to the ocean through 2 tunnels that were built 60 and 80 years ago. These tunnels have never been taken out of service since they were built because there's always flow going through them. And the tunnels were not built to current seismic standards, even though they crossed 2 earthquake faults. The tunnels also have limited flow capacity, which comes into play when it rains across the LA basin. When it rains, rainwater gets into the sewer system, and the flows to the plant and through the tunnels can more than double. The last time we almost exceeded the capacity of the tunnels was back in 2017 when heavy storms hit the LA area. So what would happen if the existing tunnels were to collapse or their flow capacity exceeded? Well, sewage would still flow into the plant, so we would have to find a way or a place for the treated wastewater to go, otherwise the plant would flood. And we can't allow the plant to flood because 5 million people and businesses across the county depend on this plant operating 24/7 without failure or interruption. So to avoid the plant from flooding, we would have to release treated or partially treated wastewater into Machado Lake, which would impact the water quality. Now, if that measure were not enough, we may have to go upstream and release raw sewage into the Dominguez Channel, which would flow into the LA Harbor and eventually to the surrounding beaches. Now, depending on the extent of damage, a collapse of the existing tunnels, and where it's located, this emergency discharge could last for weeks, months, or longer. In keeping with our mission to protect public health and the environment, we're building a new tunnel so we can avoid the situation. So if you look at the alignment of the existing tunnels shown here in the blue line, it's almost a straight shot from a plant in Carson all the way down to the beach. Whereas a new tunnel shown in the green line, it's this green squiggly line all the way down. And the reason is because we're staying underneath the streets and the public right-of-ways. And when we were doing early outreach for the project, residents along the alignment did not want the tunnel to go underneath their homes. So we're honoring that request by keeping the tunnel underneath the streets and the public right-of-ways. So now to talk about how we're building the tunnel and where we are in construction is my colleague, Russ Vicaria.
Okay, good morning, everybody, and thanks for attending today. If you've seen any of these presentations before, the first half of what I'm going to go over will be a little bit of repetition, but there's a lot of new material in the second half. So basically, the starting point for this tunnel is the tunnel shaft that we have. It's right on the border between Carson and Los Angeles. Here's an aerial view of the shaft area. And the tunnel machine was put down into this shaft and started tunneling in this direction. Here you've got the Harbor Freeway and you've got Figueroa Street. So again, the point of the shaft, and here's the ground surface that we're talking about, and here's the shaft that was excavated some time back, is to place the tunnel machine down and to start tunneling. And as you can see from this also, we're well under the groundwater level, which adds another level of complexity to this project. So the route of the tunnel is basically going south out of the shaft onto Figueroa Street, then making a right turn, going through Harbor Park, under Machado Lake, up Gaffey, Capitol, and then Western. So this shows the basic tunnel alignment. And again, you can see the streets that it goes through. The first half of the tunnel is relatively shallower. It's 45 to 90 feet deep, plus or minus. The second half, where we go under the Palos Verdes Hills, it's considerably deeper, up to 460 feet. The general tunnel machine, here's what the front of it looks like. It's about 21.6 feet in diameter. The whole head turns, and then you've got various cutting tools here that help break up the material as it's tunneling. Here's a picture of the tunnel machine. It was assembled in a factory in Germany where it was built. Here's the front of the tunnel machine, and here are the trailing gear pieces that it pulls behind. Now, this trailing gear is made up of various pieces of equipment. It's like a moving underground city. It's got to support the miners who are working in the tunnel machine and also the entire tunneling operation. So it includes ventilation, power, transformers, pumps and piping, sensors, safety equipment, and much more. So the front of the tunnel machine pulls all these pieces along behind it. In general, I've shown this slide before. Here you've got SoFi Stadium, Rams Stadium. This tunnel machine is long enough to stretch over 2.5 football fields. It's over 780 feet long, and it was delivered to the job site in over 90 truckloads and then put together. So it's a very long machine. The tunnel machine is named Rachel. We had a artwork and naming contest with the LA County Schools. It's named after Rachel Carson, who was an environmental pioneer and wrote the book called Silent Spring back in the 60s. And here's the side of the tunnel machine. You see the name Rachel here and some of the winning artwork from kids in local schools put on the side of the machine, along with the logos of some of the firms involved in this project. So the way this tunnel machine moves forward is it's got 16 pairs of jacks, and these jacks are extended, and it pushes the tunnel machine forward. So here's a little basic animation as to how the tunnel machine works. The rotating head turns. The machine is pushed forward by these jacks who push against the last erected segment ring. So you see the jacks are pushing forward, then they retract, and then inside the tunnel machine, a new precast concrete ring is erected, and then the tunnel machine pushes forward on those. And that's sequentially how it's done. And each one of these rings is made up of 6 different concrete segments. These segments are produced in a plant in Palmdale. They're brought to the site, and then they're brought to the tunnel machine using rubber-tired vehicles like this. In general, the way the tunnel machine works, and this is called a slurry TBM, is here's the outside, the dirt area, the tunnel machine's going from right to left. Here are the cutting tools. So there's a pressurized chamber here where a bentonite clay slurry mix is pumped in and kept under pressure. And this pressure is to equalize the external pressure so that you don't have any kind of ground movement. And then as the tunnel machine digs, dirt comes into this pressurized chamber, and then a slurry and dirt mix is removed from pipes, and it's taken to a separation plant where the slurry is recycled and then pumped back in to use. So this is a picture of a similar tunnel, and this is what a tunnel looks like once it's constructed. And I'm going to show you some actual pictures of this job coming up. There are 3 planned maintenance stops for this job, and what happens is we had a drill rig on the surface, and grout, which is like a cement mix, was pumped into the ground, and the tunnel machine, when it reaches the maintenance block, will drive into the block, and then it can depressurize and go through maintenance. So these 3 maintenance blocks are shown in blue. One is just west of the freeway, one is in Harbor Park, and the other one was on Gaffey. This work is all surface work. It's all been completed. So we're off the street and we're completed with these items of work. One of the important things that we need to do when we're mining is monitoring the ground to make sure there's no significant ground movement, there are no issues. So the way this is done is, here's the tunnel machine coming along. So we've set ground surface settlement points along the alignment. So if any of these move, we get notification in real time. But you don't want to wait till you get some movement at the ground surface. So we also have a series of underground settlement points. So for example, this one, you see the 3 points in yellow, one's right above the machine, one is halfway up, and then you've got the third one. So we're monitoring these also in real time. So if there's any kind of movement, we get notification right away. We also have utility settlement points on critical utilities and vibration and noise monitoring points to monitor the machine. So we've got a series of these points, the underground points, the ground points, structure points, and all these are read wirelessly by these total stations. And then the signals are sent directly to our cell phones so we can see exactly what's happening in real time. So this is an actual screen from my cell phone. And here you've got the tunnel shaft. This shows a graphic of the tunnel as it's been constructed. Here's a graphic of the tunnel machine. And these white points are the ground monitoring points. So we can see this in real time. I can see it on cell phone, computer, whatever. And all this data is transmitted in real time so we can see what's going on and make any adjustments as needed. The other thing, aside from monitoring the ground, is monitoring the tunnel machine itself while it's tunneling. So here's one of the screens that we have. Here's a cross section of the tunnel machine here. So I can look up here at any time and see, is the tunnel machine advancing, which means is it digging? Or is it building one of the concrete rings? Or is it waiting? And there are various other parameters we're watching also using this tunnel software. So the contractor has access to this. We, the district, have access to this also. And again, this information is available constantly to us when the tunnel machine is operating. And the way this works is there's a fiber optic line that connects the tunnel machine to a computer server in our field office. And this is transmitted instantaneously to our cell phones and computers. And all sorts of different parameters are being monitored, including the amount that's excavated, how much thrust force is being used, if the cutting tools are wearing, pressure, and more. So the first part of the tunneling is assembling the tunnel machine in the shaft. And again, as I mentioned, this tunnel machine is approximately this long. It's over 2.5 football fields long. The challenge is you've got to get this long a tunnel machine into this small a shaft. If you had a bigger shaft area, you could assemble the whole machine on the surface and put it down. But here you've got to put it together as you're tunneling. So here's an actual picture that was taken some months ago. We're looking down into the tunnel shaft. Here's the front cutting head of the tunnel machine, and here's the second piece. You've got a short starter tunnel here. So basically, this is the tunnel machine down in the shaft, looking at it. Here's the cutting tool. You can see the name Rachel with the artwork here. And these are the tunnel miners getting ready to start the tunneling process. And here we're looking at the tunnel machine from inside the starter tunnel. You've got these guide rails. So the tunnel miners get this machine into the starter tunnel and get it ready for mining. And here, the front of the tunnel machine's already been pushed into that starter tunnel. So you're looking at the rear of it. Here, we're inside the shaft. And here are the thrust jacks. Here's the guide rail. And this is when it was getting ready to start tunneling. So the launching of the tunnel machine, I'm going to show you a few graphics to show how it's done, because it's got to be done in pieces. So we have the shaft. Here's the ground surface on top. Here's the shaft. The contractor dug short starter and tail tunnels to logistically help launch and manage the tunnel machine. So the first part was lowering the front of the tunnel machine down, bolting it together, and then pushing it into the starter tunnel. Then they attached a piece of trailing gear behind it and bolted that together. And then they extended cables down from the surface, because in order for this machine to work, it's got to be connected to power, the slurry system, fluids, other things on the surface. And then the tunnel machine needs something to push off of. So a steel truss frame was erected so that the tunnel machine can push off it and start tunneling. So the tunnel machine pushes off it, starts tunneling. Here's the segment carrier bringing the concrete segments to the tunnel machine. And again, here are the different concrete segments being erected. as it moves forward. And again, all this is done while this machine is being fed from the surface, which is not an easy feat. So here's an actual picture that was taken several weeks ago. Here you see all the power cables, the pipelines and all going down to the machine. The head of the machine is already buried, and here's the first trailing gear piece. So this tunneling operation right now is being fed from the surface. Here's some other pictures from the shaft where you've got some tunnel miners. Some of these concrete rings are being, segments are being lowered into the tunnel, and the miners get them ready to feed the tunnel machine. On the left side here, this is an actual picture of inside the tunnel machine. So you can see that this ring has been erected. You see the different segments. Here's one segment, here's another one. And now a new ring is being erected here. And here are the thrust jacks. So the thrust jacks are extended back as this new ring is erected. Here's a little video on the right that shows it. So you see the thrust jacks are pulling back, and now you see the tunnel machine arm raising up the next tunnel segment to put it into place. And this is done sequentially by the tunnel machine as it moves forward. So once this ring is built, then these thrust jacks will press up against it and move forward. So these are, again, actual shots from the tunnel machine. And here's one of the tunnel miners bolting some of the segments together. The clearances inside the tunnel machine are very tight. And here's some additional pictures of the tunnel itself. So you've got the tunnel machine here. Here are some of the segments that have been erected in the tunnel as it's moving forward. And you see that after a segment is erected, these thrust jacks push up against the last erected segment and push the tunnel machine forward. And here's a picture of a portion of the tunnel that's already been excavated. We've gone over 350 feet at this time. It looks a little messier right now because all these cables are strung along the side to feed the tunnel machine. Once all the tunnel machine pieces are put in and the entire machine is hooked together, a lot of these cables will go away. So that's basically the overview of what's happened so far. If there are any questions, we'd be happy to take them.
All right, thank you, Russ. That was pretty fascinating. First question is how much did this tunnel machine cost to build?
Now that the contractor purchases the tunnel machine, so we don't know the exact figure, but it's probably on the order of something like $20 million plus.
Okay, and the next question, we're going to allow Sire to talk. I think we will ask to unmute. So Sire, go ahead with your question.
Good morning. Am I audible?
Yes, we can hear you.
Okay, thank you. I just wanted to know, and I don't mean to be sarcastic. I just wanted to know if Elon Musk and Tesla company is associated, because I did notice that that there was some connection between Amazon and the Clearwater project.
No, Musk and his tunnel company are not associated with this project at all.
And Amazon's not associated with the Clearwater project as well. It's a project we've been analyzing our treatment plant since 2006, and it's something that we need to do because the existing tunnels are over 60 years old. So it has nothing to do with Elon Musk or Amazon. And okay, thank you for your question. The next question, where is the slurry separation plant?
So the slurry separation plant is on the shaft site, the same area where the tunnel shaft is. It's just adjacent to it. So the pipelines come up out of the shaft into the separation plant, and then they go back down. So it's within 50 yards to 75 yards from the tunnel shaft.
And this is, I hope I'm getting this question right, Russ. The simple question is German technicians?
So this machine was manufactured in Germany, although the parts came from various different countries. The factory has also provided technicians to the contractor, some of whom were still on site as technical advisors while the machine was being put together, and also for the operation and to provide technical support.
And the next question, what distance planned? I would imagine that's how long is the tunnel, if I can,
Yeah, so the tunnel is 7 miles long in total.
okay. You really know your stuff, Russ. All right, next question. Below the water table, do the panels hold the water, hold back the water?
Yes, absolutely. Very good question. They have to be designed to hold back the water. So they have gaskets in between them. And so when they're put together, you have a watertight seal.
Okay, next question is, how do we navigate, i.e. GPS?
Very good question. It's a very challenging thing to navigate a tunnel around 30 curves over 7 miles. So there are specialized surveyors. So there's a laser guidance system within the tunnel machine that tells the operator which way to go and how to make the turns. But then periodically, when the tunnel machine stops, surveyors come in and they've got a gyroscope in there, which is highly accurate. And they check the tunnel alignment to make sure that it jives with where we're supposed to be. And it's not easy, but there are some specialized surveyors who do this all the time for other tunnels also.
Okay, great. How long will this project last?
So the tunneling itself will be somewhat over 3 years, assuming that we don't run into any significant delays. And then after the tunneling is done, we have additional work that'll go on down at Royal Palms Beach, which is over 2 years worth of work. But the tunneling itself is going to be 3 to 3.25 years planned.
Okay. And let me take a break inadvertently. We also have a poll. We want to know how we're doing. We want to make sure these presentations are responsive to what our community likes, with needs. So if you could take a second and just quickly answer a couple of those poll questions so we can see Russ's face in its entirety, because he's the star. He's the secondary star. The tunnel and the TBM and Rachel are the big star. Russ is a supporting player. So if you could answer the poll, we appreciate that. All right, next question. So we answered how long will the project last? Next question, how does one get a job as a tunnel miner? Required training?
That is a good question. The contractor is responsible for hiring their workers. And so they do various outreach events. They go to the local unions also, and so they hire workers. So the contractor can be contacted directly, and then it's up to them as to who to choose. Right now, it looks like they have the full slate of miners, but as people leave, they may need other people also.
Next question is, what is the typical advance rate?
So the average planned advance rate for this job, once the entire tunnel machine is buried, is about 50 feet a day, a little over 50 feet a day, which means that at times you're going to have to go significantly faster than that, because there are other times the machine may be down for maintenance or other things. But that rate will only be achieved once we get the entire tunnel machine in. Right now, it's a slower pace till we get to that point.
So you're saying on average 50 feet per day?
It's a little over 50 feet a day, correct.
Okay, cool. Next question, how does this machine turn for curves of the alignment?
Very good question again. So the jacks that I showed, they're used to steer the machine. The machine also has an articulating head, which maybe in a future presentation I can show. So it's not just a rigid head, it also can turn. So the operator will turn the head of the machine and also adjust the pressure on the jacks in order to make the turns.
All right, next question. Can we bore through granite, basalt, or other metamorphic rocks?
This machine can handle very strong rock material and go right through it. Now, under the PV hills, we don't anticipate the hardest type of rock. It's more like a softer type of rock. But yeah, this machine can handle significant rock, without any problems.
Okay, next question. What's the sharpest turn this machine can make?
The sharpest turn we have on this job is an 800-foot diameter curve. The machine can make a slightly sharper curve than that. You always want to design it to be a little bit sharper, but 800-foot radius is the sharpest curve we have. Okay.
And then we have a question in the chat. Do face any unforeseen geotechnical challenges so far? And
So
if so,
far, yeah, go ahead.
and if so, what were they and how do you solve them and mitigate them?
So far, we haven't gone that far. We have not encountered anything unexpected. Um, We're always prepared for encountering things that are not expected because you are going underground. And that's one of the reasons the contractor and we are constantly monitoring various aspects of this tunneling process to see, is the pressure increasing? Is the water volume increasing, or things like that happening, which may indicate a slightly different condition, and then make adjustments, based on that.
Okay. And next question, is panel installation automated or manually via
So
technician?
you may have seen that the arm that was raising that concrete panel was, it's a robotic arm. It is controlled by the operator. Many of the processes are mechanized, they're programmed, but you do have people there also to make sure, for example, that two panels sit together properly, the gaskets are put together. So it's a combination of the two. It's mechanized, computer controlled, but also there are people in the tunnel machine to make sure everything's working okay.
All right, thank you, Ruth. Next question. What is the typical pressure in the pressure compartment?
So basically, pressure in tunnel machines is measured in bar, which is about 14 psi. In general, so far we've had like 1.5 bar pressure, but this machine can go up to 10 bar plus, because certain areas, especially under the PV hills, we'll probably see greater pressures.
So could you translate what bar, what
So,
that
so
might
one
mean?
bar is about 14 pounds per square inch. So it's
So-
about 1.5 bar is what we've been mining at so far, but we can go higher.
But what would that feel like? Is it equivalent to diving to a depth of?
If somebody has to enter that cutting chamber, which is under pressure, they've got to wear breathing apparatus and they've also got to go through decompression. So it's like deep sea diving, and it would be adjusted based on how much pressure they're feeling in there. So one thing I didn't show today, which I've shown in other presentations, is you actually have personnel locks, which are like diving locks that people enter with breathing apparatus if they want to go into that cutting chamber to inspect the tools. And then depending on the pressure that's actually encountered, they've got to depressurize for a certain amount of time before they leave.
All right, a couple more questions on the pressure aspect of this. Is the selected pressure set by the water table?
Not only the water table, but the ground conditions also. So it's a combination, because the depth of the tunnel varies quite a bit. The tunnel itself is relatively flat, but the ground surface changes. So it's a combination of ground pressure and water pressure.
Okay, next question is, what's the expected life of the new tunnel?
The expected life is, to be honest, I don't know exactly, but we're talking, 50 to 100-year life, something along that line. It's a pretty lengthy life. And it should even be potentially longer.
Yeah, and the follow-up question is, will it accommodate future population waste requirements?
Yeah, that's excellent question again. So when the new tunnel is put into service, we'll dry up the 2 existing tunnels. We'll go in there and we'll inspect them. We'll retrofit them if necessary, and then we'll likely keep them in service also as backups. So there should be more than enough capacity once this project is done.
Okay. All right, next question. Are the gaskets between the panels meant to last a lifetime? And if so, what are they made of?
Yeah, so it's like a harder neoprene type material, and they're under significant compression. So they should last for, as long as the tunnel lasts. And later on, if you get some slight infiltration, it's not going to be the end of the world. You've got basically treated wastewater flowing through it. So we don't anticipate any issues with those.
Okay, I got in the chat are the tougher questions, but keep the questions in the Q&A by and large. So this individual asks, some earth pressure balanced tunnel machines struggle in mixed phase conditions. You got to explain that for most of our audience, what mixed phase conditions. are, how is slurry machine performance in your project? There's a lot to chew on there.
It is, and put it this way, that's a pretty technical question.
Yeah.
And if you want to discuss it further, feel free to contact me. We can get into it more in detail. And I've got some other tunnel experts who could get into it. So an earth pressure balance machine, for most people who don't know, it operates similarly, except there isn't a slurry mix that's pushed up against the face. But otherwise, the machines work relatively similarly. This machine should operate pretty well under mixed face conditions, which is one of the reasons the contractor selected it. And again, it was the contractor's choice as to whether to choose an earth pressure balance machine, a slurry machine, that sort of thing. So that was one, because we will be facing some mixed face conditions. That's what the contractor felt was one reason why they selected this machine.
Russ, do you want us to put your email in the chat if he wants to reach out to you, or just?
Yeah, you could do that. You could either put my email in there, or you could email clearwaterproject@lacsd.org if you have any more specific questions, either one.
Yeah, Clearwater. So we'll put that in the chat.
Sure.
The next question, at the ocean, how can we have outflow if the outlet is below sea level?
Yeah, so again, the hydraulics of this, I'm not an expert on that, but a lot of the hydraulics depends on the ocean, the tides. So, and you have pumping from the plant, but how much pumping is required depends on the tide level at the ocean. So again, that gets into a pretty detailed technical question. If you want to know more about it, how the hydraulics work exactly, feel free to contact me, and I can give you some more information.
Okay, and in the chat, we've put the website, and we've also put the email address, and
Correct.
Those locations, we'll get back to you with the answer. Another question, how loud is Rachel? How loud is our tunnel boring machine?
From the outside, from the surface, you don't hear anything. And also, you may have noticed that we have rubber tired vehicles that bring those segments to the front of the machine. Many earth pressure balance and other machines use rail. So the rail cars will make a lot of noise and vibration in the tunnel. Here we've got rubber tired vehicles, so there shouldn't be anything. When you're in the tunnel machine itself, of course, there is some noise because it's a working piece of equipment, but it's not overly oppressive or anything. And on the surface, you don't hear anything.
All right, next question is for me and Glenn. Will the recording of this be available? Yes, we'll have this recording on the Sanitation District's YouTube channel. Russ is becoming a star because of these periodic presentations. Can I say that, Russ?
No, don't say that.
Don't say that. All right, next question. Can the tunnel boring machine be used again in the future once the current project is completed?
Again, another very good question. You guys asked some good questions. So this machine will be going 7 miles, so it'll have a lot of use on it. Certain parts of it can probably be recycled and used again. The person or the group best able to reuse it is the tunnel machine manufacturer, because you'd need a tunnel exactly this size, and you'd also need a slurry machine to reuse it. But a lot of the parts, the pumps, some of the cutting head pieces, other things will be recycled and reused again. And by the way, if you look at metro jobs and others, there are some refurbished machines that have been used. So there is recycling of this material that is done.
Okay. All right, next question. This one's right down the middle of the plate. This is kind of why part of the reason we're building this new tunnel in addition to aging infrastructure. Would a significant earthquake affect the integrity of the tunnel?
Another very good question. So one of the things we will do is where this tunnel crosses earthquake faults, we'll be putting a secondary steel liner inside the concrete segments. And that's been seismically designed to handle any kind of earthquake. And that's one of the key reasons we're doing this job, is because the existing tunnels do not have that. They were not designed to seismic standard. So you don't know what may happen if an earthquake may occur. But this tunnel is definitely designed to seismic standard. And that's one of the main ways is to put that secondary steel liner in where the tunnel crosses the earthquake faults.
All right, another tunnel TBM specific question. Can the tunnel head be reused in other projects? Since the diameter is specifically designed, customized for the size of this tunnel.
Yeah, again, that becomes trickier, but to use the exact cutting head, because you'd need the exact diameter tunnel. But certainly parts and pieces can be reused and will likely be reused, on other jobs.
Okay, I think, all right. This is an interesting question. Presumably all coordination is in English. How would you rate the English speaking skills of the German technicians?
Oh.
Yeah, I'm sorry. We
Okay.
try to,
Actually, it's very good. And, they're probably used to supporting projects around this country and elsewhere. This same German tunnel machine manufacturer, Heron Connect, is providing all the machines for the LA Metro jobs also. So these technicians who they send are used to, communicating with people in other countries. Their English is very good. And by the way, we happen to have one inspector ourselves who speaks German himself, but that's not necessary. The technicians speak very good English, and there hasn't been any communication issue at all. The bigger challenge has been because of COVID, with all these travel restrictions and all, getting people here from overseas and back and forth.
Yeah, and I spoke to some of the technicians. I think one of their most recent job was in like Indiana, and they were there for a while, and they loved it. They loved the food. We had a long talk.
Correct. So that has not been an issue at all.
Yeah. All right. A question about, is the future to recycling all the water from is the future to recycling all the water from the sanitation district discharge? I'll take a shot at that.
Sure.
We have 11 wastewater treatment plants throughout the sanitation district service area, and 10 of them, all the water pretty much is spoken for. It's reused. The joint plant, the water from that joint plant has a high concentration of industrial discharge, so it's typically too salty for reuse. So we're on a parallel track. We're working with Metropolitan Water District of Southern California on a water purification project that's in its early stages. We built a demonstration plant, a small demonstration plant. We want to prove up the technology, get the appropriate permit, and then approval from Metropolitan Water District's board and our board. And if those go ahead, then we could, down the road, build a purification plant at the joint plant. So more of that water, or the plant in Carson, more of that water would be recycled. But nonetheless, we need this new tunnel to make sure that the joint plant reliably provides wastewater treatment, because the existing tunnels, I think the second one was built in '58 and they haven't been taken out of service. And everything that's not reused has to go through those tunnels.
Hey, Basil, and let me add one other quick thing is, what many people may not realize, and what surprised me also years ago, is when it rains,
Oh yeah.
basically the inflow into the joint plant can more than double. So when you recycle water, MWD or other agencies who take our water, they want a steady stream of water. But you get serious peaks when you've got heavy rains. And so you're still gonna probably, I'm assuming, gonna have to have these tunnels available to discharge water, even if you recycle more and more water. So they kind of go hand in hand, but that's one of the things that's interesting, is how much additional flow we get when you get heavy rains.
That's a great point. I totally forgot that. Yeah, I think in 2017, when it rained really hard, that plant got real close to the edge. I mean, I think Glenn showed that in his presentation. That was just down the road where the roads were flooded and the treatment plant came within inches of not so good a situation. So we're seeing more extreme weather that's putting our plant at jeopardy. All right, next question. With hard rock, how often are the cutting heads replaced?
Again, very good question. Even in soft ground, sometimes depending on how abrasive the soil is, tools have to be changed. So It's the contractor's judgment as to how long they can go without inspecting those tools and changing them. They do have some tool wear indicators and some other parameters that give them some indication of tool wear, but it's really going to depend on the particular conditions. And they'll have to make reasonably frequent inspections of those tools to make sure that they're not wearing out.
All right, I think we don't have any more questions, Russ and Glenn. Thank you for really enlightening update on the construction of the Clearwater Tunnel. Anything else you'd want to add, Russ or Glenn, before we sign off?
No, just thanks for attending. And if you have any other questions, feel free to contact us.
Yes, thank you so much for spending your Saturday morning with us, and we will be having another update as Rachel makes her journey, her inevitable journey to the ocean. Thank you, folks. Have a great Saturday, and thank you for joining us.
Bye, everybody.
Thank you.
Bye.